chips are really at the heart of the growth that we are seeing in the world.
We're in a computer chip shortage, and the world needs new solutions fast. Everything we do revolves around chips.
We use hundreds of chips in a car, and you know how many thousands of chips are used in a data center? How we communicate with each other, it's all made possible because of chips.
Not only do we need to address the chip shortage now, but we also need new chips and new ways to design them. There's also a growing need for new types of computing resources to run complex AI models, advanced quantum computers, and to support massive hybrid cloud systems. That demand could be aided by the recent passage of the CHIPS and Science Act, which allocates billions in funding for R&D of new chips here in the States.
I believe the reason why companies like IBM are choosing to build in America is because we're better positioned globally than we have been in any time in a long time. The supply chain is going to start here and end here in the United States.
Part of that solution could be found in upstate New York. So I'm outside the state capitol here in Albany, New York, to find out what makes this region so special and why IBM and so many other tech companies have a long history of research here that ends up in chips. In and around Albany, there's a long history of semiconductor research and production. For years, IBM has been the largest tenant of the Albany Nanotech Complex, which is owned by New York Creates, a partnership run by New York State and the State University of New York.
Albany Nanotech Complex is one of arguably only 2 or 3 sites in the world that have the capabilities that we have that are open access to most of the industry for developing new technologies. The products, the technologies, the device structures, the things that have been developed here are really going into next generation systems.
The facility in Albany has been at the center of some of the biggest breakthroughs in computing. Chip designs that have come from within these walls make it all the way to the devices that are used by businesses and people the world over.
In 2021, we announced world's first 2-nanometer chip technology. A couple of years back,
our chips from our contamination. This is a clean room facility. Any small defect that goes into this chip can create a failure. So people need to be dressed in bunny suits to keep the environment clean.
And then it was my turn to be the guy in the suit, to see the science and innovation behind these glass walls. That's not right. Ow!
It's the closest I'll ever be to Darth Vader.
I'm struggling here.
Yep.
I'm like a large white penguin. Okay, we're going in. This is cool.
So here we have our fab. We're now inside the fab. Over here, we have the big lithography tool that actually pattern the wafers.
It is so big. It's
You can add the size of the bus, as you can tell. You can bring it in. I think it needs about 3 cargo planes.
Really?
So it's insanely big. Underneath this machine, there's an equally or even larger infrastructure that holds a laser. This laser impinges upon very small tin droplet. That tin droplet, when the laser impinges on the tin droplet, it generates EUV light, which is collected, focused, and used to create the pattern on the wafer.
So it's a really fancy Etch-a-Sketch is what you're telling me.
That's what I'm telling you. The work that we do here now will allow us to have better performing devices in a decade or so.
Researchers like Nicole Saulnier of the IBM AI Hardware Center are looking at the new types of chips that emerging workloads require.
Yeah, so this is our offline lab space.
Okay.
And what we're doing in here is taking those wafers, we bring them in, and we can do additional testing. We have capability to do what we call parametric testing, which is a little bit more simplified, testing a device or a structure. And then we also have capability to do what we call functional testing, where we're testing actually the whole chip. We are able to test our chips before we send out the wafers for dicing and packaging, so we can pick which chips are going to be good or the best, and send those on to our colleagues at the Worldwide Lab.
Today, most AI inferencing is done on GPUs, chips originally designed for processing graphics on a computer.
Models are getting larger, data sets that we're using to train models are getting larger and larger, and so there'll be a time when we can't just throw more compute at the problem. So instead, we need to look at new ways of tackling the problem, either through digital cores or through analog in-memory computing, and even other solutions like heterogeneous integration, where try and put together different pieces in novel ways that will help to make the overall system more efficient. So these wafers are here waiting for us to go take them over to the test lab and do a little bit more work on them.
The team is on a mission to accelerate the development of AI hardware and meet the growing demands of AI processing, both for IBM and its partners. But none of these breakthroughs happen in a vacuum. If it weren't for the strong community that New York has fostered around Albany, little of this would have happened. In this building alone, there are researchers from Tokyo Electron, SUNY Poly, Applied Materials, New York State, and Samsung, all working on projects that are changing the future of chips. And they've been brought together by New York Creates.
Well, we're very proud of the capabilities and the facilities that we have on site. Our mission is really to accelerate next generation semiconductor and adjacent technology development with a strong focus on education, workforce development, and helping to grow the innovation economy, particularly across the state of New York.
Tokyo Electron is one partner that IBM collaborates with closely to optimize chip research and production.
For TEL, our competitors, our customers, and our partners all work together in this one-of-a-kind ecosystem. And we've all learned how to coexist here and take good advantage of the opportunities. With IBM, we've perfected how we work on R&D over the past 20 years.
What happens in Albany is only possible because of the collaborative community that's been fostered here.
I'm very proud of how public, private, and academia work together. I'm very proud of how many companies are collaborating. It's a unique model in the world. And at the end, our goal is to create the best product for our companies and bring best talent that can join the workforce of future.
In the past, Albany has helped usher in the computer age we currently live in. And the research happening today has the potential to change how we discover new materials, cure illnesses, communicate, travel, work, and frankly, just live.